Hello, everyone. Hope you all are having good time at the summit. Welcome to our talk, Automated Metadata Management in Data Lake, a CICD-driven approach. In this talk, we will show you how easily and effectively you can manage and maintain schema in your own data lake environment. I am Keurisha, lead engineer at Northwestern Mutual. I have been with NM for past 10 years and part of various innovation projects. My most recent one was to create a big data platform for our field reporting space. I am accompanied with my colleague Josh here.
Hi, I'm Josh Riley. I am also a lead engineer at Northwestern Mutual. I've worked for the company for 9 years. My background is mostly in web development. However, I recently had the opportunity to work on an exciting new project using Spark.
Thank you, Josh. Before we get through the agenda here, let's do a quick introduction on who we are and our legacy. Northwestern Mutual is 160 plus year old Fortune 102 company that provides financial security to more than 4.6 million people. We deliver this through a holistic approach that brings together a trusted advisor and a personalized financial plan that includes insurance and investments powered by technology to drive a seamless digital experience for our clients. Technology accelerates our business and company strategy to deliver this digital experience to our clients. It also helps our 10,000 plus financial representatives throughout the country to better serve our clients. We have been a digital transformation journey for several years now, and the pace is accelerating more rapidly than ever before to meet the needs of our consumers today. We have recently gone through a migration effort to transform our BI space to a big data platform, which uses Databricks as our ELT tool and the Delta tables as our storage for the data lake. There is a talk during the summit titled Northwestern Mutual's Journey, Transform BI Space to Cloud by myself and Madhukodian. If interested, I would recommend attending that. Well, coming back to our agenda here, we did go through a quick introduction. We will now go through why we need metadata management, do an architecture review of our tool, and then Josh will deep dive into the demo, which is pretty exciting. So let's start here. Need for metadata management. Let's start by asking two basic questions. What is metadata and why do we need to manage it? Well, if you are a user or a developer or analyst of any traditional database like MySQL, SQL Server, etc., you will be aware of impacts that can occur if there are changes to any kind of metadata. And when I say metadata, I basically mean table names, database names, column names, view names, etc., etc. You all know about it. Sometimes the impact is as simple as I just need to update my query to accommodate the changes, or it becomes as big as bringing all the downstream systems down with multi-one P1s across the organization. And hence we need a way to govern our changes, especially around metadata for our tables, columns, databases, etc. in our data space. That is pretty much metadata management. To manage the metadata, to govern it, to simplify it, there are different flavors of managing metadata. It may sometimes vary from organization to organization, and it may also vary from different teams in the organization based on what capacity you need to do it. Sometimes it may mean you just manage through emails to the whole group. You just send an email saying, hey, I'm updating this column name. Or you may have to rely on more automated systems, depending on how your team it may or may not impact the downstream systems. Well, there is one part to it, but another part is taking approvals. So while informing other teams about changes, in one part is taking approvals is another. For some it may be approval from your team lead, but for others, it may mean approval from different downstream systems, team leads you may be working with. While you are working on governance and approvals, making metadata changes to production systems needs to be more automated. In order to protect your production data lake, you would want all the changes going in through an automated process, hence eliminating need for manual intervention. This makes our systems more reliable. It also builds a more robust, mature, and a repeatable process. Another important thing is usually overlooked as easy to maintain. While you are building this process that can help you with governance, that can help you with approvals, it needs to be easy to use and easy to maintain. It shouldn't take you a long time, or maybe more time than you actually do to develop to maintain your metadata. In that case, it will not be widely adopted, and adoption is the key here. So always keep in mind something like this. When you want to make it more widely usable, it needs to be easy to maintain. Now, what would be the different use cases that you would want? Something like a metadata management at a more automated and a tool level. Well, one obvious case is if you have an enterprise-wide data lake or a data warehouse, you would want to manage your data because there are so many downstream systems, a lot of people using your data. It just becomes more important to govern your metadata, to protect your metadata. More number of people or teams you have using your data, it just more critical, it becomes and transparent about the changes. Now, let's talk about what we have built here at Northwestern Mutual for our field reporting team in terms of metadata management. We have a lot of downstream systems, um, and hence it was important to put some governance and approval in place. I briefly touched last time on you needed to be easy to maintain and easy to use. Hence, we have adopted the philosophy of making a config-driven approach. Well, it's basically a YAML file, which is obviously you can make it or create it very easily. It's easy to read, even for people who are not developers, business analysts, product managers, anybody can come and read these files. And hence we want it to be easy so it can be widely available. That's the whole philosophy this tool is based on. And in coming slides, we will deep dive into what config file means and different options on the config files. You would use this tool to manage your schema at the table level. So let's say you have an ID field, that's an integer, a name, that's a string, payment, that's a decimal. All of those would be managed at a schema level file. So any changes that you may need to do is basically updating the file, checking in, and the tool will automatically create to make the updates available to your Databricks or the Delta environment. It is also used to do access management. Now, what I really mean by access management is, like I said, we have all these different teams accessing our data, accessing our databases, different views. We want it easy to say, well, we have a new team coming in now. Who gets access? Like, how do they request for this access? Well, at this point in time, it means as simple as you make the config changes, you add your AD group, and then the tool goes in and does all different kind of grants to give you access to all the tables and databases that you need to. In addition to that, what we also do is our PII data management. Security is a first-class citizen at Northwestern Mutual. We think security first. We need to protect our PII, PHI information. And again, because it's so important, it needs to be easy to identify and put it in. And hence, what we have done is we have created in our metadata tool, whenever anybody is creating a table, they would identify what's PII and PHI information. And the tool will go ahead and identify those at a table properties level. And then again, access management, we would say, well, who has access to PII information? And then the tool goes in and creates the grants accordingly. So they will have appropriate knowledge about it. Now, it's not just important from creation point of view, it's also important when we want to, after a year down the line, we want to know who has access to our PII information. At that point in time, it means you look at the config files, And from there on, you can see, okay, these AD groups or these users have access to PII information. So that's all about our metadata tool. Now, from development tech perspective, we use Python as our core programming language and use Git CI as our CI tool. Our data lake is mostly on the delta tables here due to all the different benefits it gives. Hence, for our talk here, we are going to limit this to managing our metadata to the delta tables. So let's talk about our design here on how our metadata tool is created. Over to the left on the CICD box, if you guys look at that, there are two steps to our process here. One is a plan job and one is an apply job. If you guys use Terraform or something like that, we would already be aware of what something like this is doing. But in a nutshell, plan job will tell you what it will be doing when you apply a job. So it's not like it will always go in and make the changes. Let's say you are creating a table, it will spit out create table scripts. If you are updating a column, it will spit out update table columns. And once you verify that everything looks good, you can then go ahead and hit the apply button, and that will actually move all the things to the Databricks environment. So our step one here, over to the top, going to the S3 bucket. As soon as you make changes to the config file, and I think this will be more clear when Josh goes through the demo here, but our step one is to upload the config file to our S3. We use S3 as our storage for all of our config files. Our step two here, over in the middle, is runs and wait for the jobs via jobs API. So we use jobs API to do a lot of our analysis here. It goes into our metadata framework job, which is on the right. And our step three here is it reads the plan output from the plan job via the JDBC using Databricks Delta. So that's mostly how our plan job works. Now on the apply job, you basically takes in the jobs API. Via the jobs API, it will actually apply the changes that it have already built using the plan job. Over to the right bottom on the metadata framework job. That job has two stages, like we talked about, a plan stage and apply stage. We have different planning modules in our metadata framework. A database planner, a table planner, and a view planner. That's basically all the different options that we provide right now through our metadata framework. Moving on, we talked a lot about what are different configuration files. We talked about how this whole framework is driven by the configuration files. Let's deep dive. What does this config file means? So starting from the database, as I said, these are all easy to read YAML files. Starting from the left here at a database level, what all information you would give when you are checking in a database file. You would start with the name, owning team, description, what kind of access, like I talked about different AD groups, who has PII versus non-PII, type, which is data. And then coming to your middle here, what are different table options here? So we would start with what is the name of the table, what is the description of the table, provide a schema for the table, what are different encrypted columns versus masked columns. And the way it's organized is in the database, you have all the files for the tables and the views. So it kind of knows that this database, I'm supposed to create all these tables in. Now, what does encrypted columns and masked columns really turn into? Well, they are basically table properties. And our ELT job then uses these table properties to encrypt all of this column and do a column level encryption. The reason for me saying this is you can make it to use whatever you want or whatever makes sense for your organization. Maybe it makes sense to put owner in. Maybe it makes sense to put team in. It can be any kind of key value pair. So the limit is the sky. Sky is the limit here. You can use it with however configuration you want at the end, what it ends as a key value pair in a table properties. Pretty similar to what does it mean on the views. You have the name in, you have the database in, you have description in, and you have a query in. These are the config files, the major config files, and sort of like a 10,000 feet view. We have a lot of different intricate details here, but like I said, it can be configured to what your organization needs. I think we talked enough on the how it would work. So we'll do a quick demo. We will create a database, a table, and a view config file, check into Git. We'll run the CICD pipeline, and we will see how does a plan look like. And we would apply it to our int environment, verify the database table in view in Databricks, and then we would actually also update a schema and show you guys how that would all works. So Josh, over to you.
Thanks, Kiri. I'm going to walk us through what this looks like from the developer's perspective. This is the repository where we keep all of our config for this framework. Inside the config folder, we have a folder for every database in our data lake. We have the stats database. This database has the table that the metadata framework uses to store its plan. And I'll open up the database config for that. And here's the metadata plan table. For our demo, we will be creating an AI Data Summit database along with a couple tables and a view. So that'll be its own folder. For the database config, we'll have two databases, one to hold the tables and the other to hold the views and to have access granted. Now we'll pop over to Databricks. Our Databricks environment does not have the AI Data Summit databases yet. As you can see, it's mostly empty. We also have a table for attendees. And if we had columns that needed encryption, you could add them here. And we also have a table for organization. And we also have a custom view for all attendees. The schema for these tables, as well as the query behind the view, are kept in the same folder. So you can see schema attendees, schema organization. I've committed these config files already, so the next step is to run our CICD. And our CICD has a job for each stage of the framework: plan and apply. Let's give it a second while it's queuing up. Okay, let's run the plan. The plan job has a bunch of steps, including pip installs, so I'll fast forward through that. Here it is merging our config files together and uploading them to S3. And then at the bottom of the screen, we have triggered the framework to run through the web API on the plan stage. And right now we're just waiting for it to finish. And while the job is running, we're pulling the web API for status changes on the job. Okay, so the CICD has printed out the status of the job as well as the plan for the changes that the framework will make during the apply stage. It read these out of the table using JDBC. It will create an AI Data Summit database. It will create a folder and initialize the attendees table. It will create a folder and initialize the organization table. And it will create the AI Data Summit View database. And it will create our custom view for all attendees. And it will create a view for each of the tables. Remember that we wanted to grant permissions to the view database rather than the database with the tables. So we have customized our CICD merge config step so that it publishes a config that has all of the tables generated as views for us. Now that we've reviewed the plan and it looks okay, we can go ahead and run the apply job. This job needs to do a pip install as well, so I'll fast forward through that again. And here it is, triggering the framework through the web API on the apply stage. The CICD printed out that the job ran successfully. So let's go take a look in Databricks. We now have our two databases that we expected. The AI Data Summit database has the two tables that we wanted. And the AI Data Summit View database has the three views that we wanted. Now let's take a look at an update scenario. To update the schema on one of our tables, we can edit the schema file. So here I'll open the schema attendees, and I will add a created timestamp to our attendees table. And I'll push that into Git. Now we can run our CICD jobs again. Starting with plan. Plan shows that the attendees table is going to have a column added. This looks good. It also is going to recreate the view that has, so that it has the created column in it for attendees. This looks okay. So we'll go ahead and run our apply. And the applied job shows that it completed successfully. So if we jump back into Databricks, we should see that the table has a new column created. Yep. And we should see that our attendees view also has the created timestamp column, and it does. Back to you, Kiri.
Thank you, Josh. That was an amazing demo. So, like we did see how easy it was to manage our metadata here. It wasn't as complicated as we have to go in and change 10 different files at 10 different systems. We can just manage it all within using a single config level YAML files at any level you want. Not just make it automated, but we can also put in some fine-grained access control so you all can tighten your security more. We can put approvals in place now that it's all in a single source control. However you want to, either your team lead approves or your director approves or approvals from various downstream systems, all that can be baked in with respect to your source code approvals. We also saw how easy it was to just catalog your PII PHI fields. A little bit of extension to it. What we do is we have a similar ELT framework where we now consume this PII PHI fields and we put more of a column level encryption on top of it. There's a call scheduled in the summit to talk about our ELT framework. So if this felt interesting to you, I'm sure you guys will like that. So do attend that or watch that on YouTube whenever you have time. Not just that, but doing this whole thing, what means overall is less outages and less impact to our downstream systems. Wrapping up, looking forward to any question and answers you have. You can hit us on LinkedIn. Here are our URLs. And please don't forget to rate and review this session. Thank you, everyone, and have a good day.